Good morning, everyone. Myself, Shivanand, Assistant Professor from Mathematics in H&S Department from TKR Engineering College. So today we discuss about the binomial distribution. So what is mean by binomial distribution? Before that one, there is a two different type of random variables are there. We'll discuss about the random variables. Then only we'll go for a binomial distribution. So random variable means randomly we have to do the any experiment. If if you toss a coin, there is a probability to get head or tail. Means that is a randomly experiment you are doing. So we'll get the random variable h and t. Simply we have the die. So die have the totally six faces. So if you throw the die, you will get the random variables are 1, 2, comma 1, 2, 3, 4, 5, 6. So depending upon the your object, you will get the random variables. But here there are two different type of random variables are there. First one is discrete random variable, and the second one is continuous random variable. So what is mean by discrete random variable? What is mean by continuous random variable? We'll discuss now. So after this one, we have the probability distributions. Depending upon the discrete random variable, we have the probability distribution, and depending upon a continuous random variable, we have the continuous random probability distribution is there. So in the discrete random variable distribution, there is totally 5 discrete probability distributions are there. In that one, main important one is binomial distribution. Today we'll go for a binomial distribution. So first of all, wait a second. So now see here. So this is a random variable about the just now only I discussed random variable. A random variable capital X is a real valued function from a sample space S to the real number capital R. Or you can call it a random variable capital X is a real number which is determined by the outcomes of a random experiment. Just now only we discussed. If toss a coin, you will get H or tail. Means head, H means head and T means tail. And if you take one game, then you will get the result win or loss. Simply in general life, we will get so many solutions, so many experiments we will do in general life. So we'll get that one is sometimes it will be fast, sometimes it will be fail. So these are the random variables. So depending upon the random variables only, we can get the total solution. So here the two types of random variables are there. So first one is a discrete random variable. A discrete random variable is a random variable capital X is said to be discrete if it is takes only the value of 0 to n. Means the particular number, if you know that one, then you can call this one is a discrete random variable. So if you don't know, if you know the particular number, means a particular number means suppose 0 to n only means sometimes coin. So coin, if you take out the coin, so you will get 2, and die you will get 6. Like a game, you will get totally 2. So like that you can take it. Means if you are getting the particular number, then you can say that one is a discrete random variable. Here the best example is tossing a coin, throwing a die, number of defective items in a bag. So these are under comes the discrete random variable. And after that, we have the one more random variable is there, that is continuous random variable. Here, in this continuous random variable, a random variable capital X, which takes all possible values given the interval of the domain. Means it is a finite. Before this one, the discrete random variable is finite. But in this continuous random variable, we'll get infinite numbers. So how we'll get the infinite numbers? Heights, weights of the students in a classroom. Means there is a sub interval will be there. Means suppose in a classroom, everyone have weight some 50 to 60 kgs. So we can assume that one someone is 50.5, 50.3, suppose 51, 52, 53, like this will be there. Means in a such interval, the heights will be, the weights will be, will take that. So continuous random variable is a random variable x which takes the all possible values in a given interval. So this is about the random variables. So now we'll go for our original topic is uh, uh, binomial distribution. Wait a second. So binomial distribution is a part of discrete random variable, discrete probability distribution only. So in a discrete probability distribution, we have the binomial distribution. So there is totally five distributions are there actually. So this is a binomial distribution. So in a discrete probability distribution, there is totally five. First one is binomial distribution, and after that is Poisson distribution, and the next one is rectangular distribution and negative binomial distribution, and the last one is geometrical distribution. So totally the discrete random discrete probability distributions are totally five. So totally five. So in this one, first one is the binomial distribution. So what is mean by binomial? The main and important topic is binomial distribution only. The first one is in this, the what is a binomial distribution means a random variable capital X has a binomial distribution if it assumes only non-negative values with a probability mass function given by P of X is equal to R, where NCR is NCR into P power R and Q power N minus R, where R is equal to 0, comma 1, comma so on up to N, or 0 otherwise. If you not countable, it is a 0 otherwise. Means simply they are saying that one means here you have to remember one point. So simply they are saying the binomial distribution is nothing but NCR P power R Q power N minus R. So this is nothing but a binomial distribution. Means we have to take only non-negative values. There is no negative values in a binomial distribution. So you have to remember it. So the apart from the for the negative values, we have the negative binomial distribution is there. That is a separate topic is there. So what are the conditions to apply the binomial distribution? First one is number of trials must be a finite. Means the such a number capital N, whatever will be there n, that is a finite. Then next one is the trial are independent. So it is not a dependent. We have to remember these are things. And the third one is there are only two possible outcomes in any event, maybe success or failure. So mainly you have to take success is P and failure is Q. Always you have to take success is P and failure is Q. So if you are taking the success plus failure, then it is equal to 1. So P plus Q is equal to always equal to 1. And the probability of the success in each trial remain constant. You have to remember sometimes only one experiment that means binomial distribution. When you are applying that one, it must be a probability of success in each trial will be constant. It is not changes. So these four conditions, if you are applying the any problem, you can apply the means if these four conditions are satisfied, then you can apply the binomial distribution. Once again, I will repeat it. So the binomial distribution is nothing but about the random variable X has a binomial distribution if it assumes that only non-negative values with a probability mass function NCR, P power R and Q power N minus R. So the conditions of the binomial distribution is number of trials must be a finite. Number of trials must be a finite. Second one is the trials are independent and there are only two possible outcomes in any event. That is maybe success or failure. Means success always you have to take the P and failure you have to take the Q. The probability of the success in each trial remain constant. Now we go for some examples. Tossing a coin n times. Means tossing a coin you will get sometime first time you will get or second time whatever will be there n times you will get only head or coin, head or tail. Means that there is only outcomes, there is possible outcomes only two are there. So the next one is means you can count it. So you can count it. That's why you are taking this one is a binomial distribution. If suppose you have to take a head is P, then the tail will be Q. So you have to take if head is a success, then failure is your tail. And the second one is throwing a die. Now see here, throwing a die. Die has the 6 faces. If I want one face to show that one, then means remaining all are remaining 2, 3, 4, 5 are failures. You have to consider that one is a failure. So number of defective items in a box. If a box contains some n items, number of defective items also we can find out and we can calculate that one. So these are the examples of the binomial distribution. Next, mean of the binomial distribution. There is a characteristics of the binomial distribution. So first one is mean of the binomial distribution. So mu is equal to the standard formula of mean is nothing but mu is equal to summation r is equal to 0 to n r into p of r. Here p of r is nothing but probability of your binomial distribution, that is nothing but NCR p power r q power n minus r. So you will get it. Finally, you will get mu is equal to mean is equal to NP. Mean is nothing but your estimation or expected value. So the mean of the binomial distribution or estimated value of the binomial distribution is nothing but n into p. And here p plus q is equal to, always you have to remember, that is 1. Means success phase failure both are equal to 1. Next, variance of the binomial distribution also, if you consider the original basic definition, sigma square is equal to summation of 0 to n r square into p of r minus mu square is equal to mu square. Then if you solve this one, you will get again npq. So here you have to remember, so mean of the binomial distribution is nothing but np, and variance of the binomial distribution is nothing but npq. Based on this one, we have some problems are there. So this is about the characteristics of binomial distribution. So in the binomial distribution, you have to remember the binomial distribution, very, very important. The topics are where you have to solve, you have to find it p, and you have to find the q value always, and n they will give. So these are the values. So you have to identify what is the p and what is the q and what is the n. So n is the number of times the event will be occurs, and p is nothing but sometimes it is a success, and q is nothing but it is a failure. You have to take the opposite of p, because p plus q is equal to, you will get always that is equal to 1. So this is the main important topics are basic information of binomial distribution. Now we'll go for a binomial distribution form problems. So in the first problem, so now see the problems. So this is about the problems. Okay. Now the first problem is, in a tossing a 10 coins simultaneously, find the probability of getting, first one is at least 7 hits, second one is almost 3 hits, and third one is exactly 6 hits. Now listen here, the given number of coins is equal to 10. So that is simply, that is n is equal to 10. And whenever they are given the coin, about the coin, always p is a success. P is, you have to take the head, and q is nothing but not head, that is tail. So p is equal to 1 by 2 and q is equal to also 1 by 2. Then they are asking about to find the first one is at least 7 heads. At least 7 means from 7 you have to start it. Totally 10 coins means from 7 you have to start it. 7 plus 8 plus 9 plus 10 means totally you have to find the 4. So p of x greater than or equal to 7. So p of x is equal to 7 plus p of x is equal to 8, p of x is equal to 9, and p of x is equal to 10. And according to your binomial distribution formula, NCR, p power r, and q power n minus r. So where n is equal to 10, p is equal to 1 by 2, and q is equal to also 1 by 2. According to the r, it will be various. If suppose p of x is equal to 7, r is equal to 7, p of x is equal to 8, r is equal to 8. And p of x is equal to 9, r is equal to 9, p of x is equal to 10, then r is equal to 10. So if you simplify these all things, you will get the total answer is nothing but 0.1719. So 0.1719, that is 176 by 1024. Now the second question is probability of getting at most 3 hits. At most 3 hits means last maximum value is 3. So before the 3, we have the values are 0 plus 1 plus 2 plus 3. So up to 3, you have to find it 0 to 3. So here also the same formula NCR P power R Q power n minus 1. So the same formula you have to apply here. So some the R value is varies from the x is equal to 0 if R is equal to 0. If x is equal to 1, then R is equal to 1. If x is equal to 2, then R is equal to 2. And if x is equal to 3, then R is equal to 3. So if you simplify this one, again you will get the value that is nothing but 0.1719. So at last, the third problem is probability of getting exactly 6 sets. Means they're asking about a total 6 sets. Means R is equal to they're asking about 6, exactly 6. And for this one also you have to do the same formula. NCR, P power R and Q power n minus R. The same formula you have to apply here also. So you will get the answer is 0.205. So this is a basic problem. In the problem they given n value and coin they given P is equal to 1 by 2 and Q is equal to also 1 by 2. So there are 3 problems are there inside this problem, at least 7 means. So we have to take from 7 to 10 and at most 3 heads means up to 3 values you have to take it. Exactly 6 means R is equal to 6 you have to take it. Now we'll go for a second problem. In a second problem, they're asking about in 256 sets, 12 tosses a coin of a coin. In how many cases one can be expected? 8 head and 4 tails. So here they are asking about here some different type of question. So 250 sets of 12 tosses means n is equal to 12 they given, but 256 times you have to do it. So n is equal to 12 toss coin. So here also the whenever they give the coin about the coin, so you have to take always that coin is nothing but P is equal to Q, P is equal to 1 by 2 and Q is equal to 1 by 2. So in this one, so you will get the P is equal to and Q is equal to both are same. So now P is equal to 1 by 2 and Q is equal to 1 by 2. So here, now see here, in the first problem and the second problem, both are about the coin only. So but first I have to explain how to take the P and Q values in a binomial distribution first. So you have to remember always P is a success and Q is a failure. So that's why P you have to take 1 by 2 and Q also 1 by 2. There are only 2 possible tosses. If the tie, if you the different case the tie have the totally 6 faces. So each face has a 1 by 6, each face has 1 by 6 because all are equal. Like coin, like then die also all are equal. So P comma Q all everything will be 1 by 6, 1 by 6, 1 by 6, 1 by 6. So that is a scenario about the binomial distribution. Now we'll go for a second problem. Wait a second. Now see here the second problem. We stop here only. Now continue this from this one. The second problem is saying that one in a 256 sets, 12 tosses a coin. In a how many cases one can expect 8 heads and 4 tails. So here n is equal to 12 by seeing only you can say, and they given the again the coin. Then P is equal to Q is equal to 1 by 2 comma 1 by 2. Then here you have to find 8 heads. In a 12, 8 heads means the remaining 4 are tails. You have to remember if they are asking you 12 toss coins, then here 8 heads means the remaining all are tails. Means if heads is there, these are the tails. 8 plus 4 is nothing but 12. So I have to take P of x is equal to 8 or P of x is equal to 4. Both you are getting the same answer. So don't confuse that one. If P of x is equal to 8, whatever the answer you are getting, P of x is equal to 4 also, you are getting the same answer. The answer is 495 by 2 power 12. Now, they are asking about 256 sets. Then you have to multiply with 256 sets. Then whatever the answer you are getting, that is the final solution. Means the answer is getting, you are getting 31. So this is a different type of problem. Means they given the same problem above, but in terms of words, now in terms of explanation, this one. Now we'll go for a third one. In the third problem, they given find the property of getting even number 3 or 4 or 5 times in a throwing a die. Now the complete changes the scenario of the die. So when you are dying, totally 6 phases are there, and each phase has a 1/6 choice. And one if you are showing the one, you will get the 1/6, and if you are showing this two also, you will get the 1/6. So each phase you will get the 1/6, 1/6, 1/6. Now here the problem is they are asking find the property of getting even number 3, comma 4, 3 or 4 or 5 times in a throwing a die 10 times. So here they given n is equal to 10 and 3 comma 4 comma 5. Totally there are 3 terms are there. 3/6 that is nothing but 1/2. So 1/2 that is nothing but P. And if P is equal to 1/2, then Q is equal to automatically 1/2 because P plus Q is equal to 1. So then P plus Q is equal to 1, then Q is equal to also 1/2. Now the getting a 3 comma 4 comma 5 throwing a times so means you have to take the according to your R values, P of x is equal to x is equal to 3 and P of x is equal to 4 and P of x is equal to 5. So you have to take it and in this one only R value will be changed. LCR P power R can Q power n minus R. So here R is equal to some the first value R is equal to 3 and R is equal to 4 and R is equal to 5. The n value is 10. And according to your P comma Q values, you will get the 1/2 comma 1/2. So the final answer is 0.568. Now the fourth problem, we'll go for a fourth problem. So it is about the not a coin, not a die. So it is about the families. So out of 800 families with 4 children each, how many could be you expect to have the 3 boys, first question, and 5 girls, second question, and 2 or 3 boys, and the third one is at least 1 boy. Now see here, this is different scenario. They're asking about the families. Here also the families means will get only male or female. So, but so male you have to take the 1/2, that is nothing but P, and female you have to take the miss boy is 1/2. The meaning is boy is 1/2 and girl is 1/2. So if you are taking the P is equal to 1/2, then Q is also 1/2. They're asking about the first one is 800 families are there, 4 children, 4 children each. So they given n is equal to totally 4 and capital N is equal to total families are 800. Now we have to go for a, sorry, this is maybe here not a 4, it is a 5. So it is a print mistake. So totally 5, n is equal to 5. Now they're asking about, they're finding 3 boys, exactly 3 boys means P of x is equal to 3, you have to find it. So 3 means n is equal to 5 and 5C R means NCR P power R Q power n minus R, where P and Q are nothing but 1/2 comma 1/2. So here P of x is equal to 3, 5C3 and 1/2 whole power 3, 1/2 whole power 5 minus 3, you will get to 5/16. The expected number is nothing but 250 families. Into you have to do it to 500. Into you have to do 800 families. So if you do it into with multiplication of this one, you will get 250 families. So you will get exactly having 3 boys. And the second one is a property of having 5 girls. So 5 girls means P of x, there is no boys. So 5 children are there. So in that 5 children, they are 5 girls. So if you take P of x is equal to 5 or if you take Phi of x is equal to 0. If you are considering the boys, P of x is no boys means all girls are there. All girls means girls strength will be 5. So no boys means the strength will be 0. If P of x is equal to 0, again you will get the 1/32 and again you have to multiply the with 800, you will get 25 families. And finally third one is property of getting either 2 or 3 boys. So 2 or 3 boys means P of x is equal to 2 and P of x is equal to 3. You have to do it. Then again R will be changes. LCR P power R Q power n minus 1. R is changes. What is the R value? If we are doing the P of X is equal to R is equal to and P of X is equal to 3, R, then R is equal to 3. Then you will get 5 by 18. And after that 5 by 18, you have to multiply with 800, you will get 500 families. And at last, the last problem is the probability having at least one boy. One boy means at least one means at least one means P of X is greater or equal to 1. So 1 minus, you can do it like this, P of 1 minus P of X is equal to 0. Otherwise, you can start with P of X is equal to 1 plus P of X is equal to 2 plus P of X is equal to 3 or P of X is equal to 4. Means you can do it 1 comma 2 comma 4 comma 5, you can do it, or otherwise totally the unit is 1, from that one you have to subtract 0. So you can do it anyway. So you can do it in anything, you will get the answer. Here R is equal to, here R is equal to nothing but X is equal, R is equal to 0. Then if you are applying this one, 1 minus 5 is 0, 1 power 2 power 0, and 1 by 2 whole power 5 minus 0, that is nothing but by 31 by 32. The expected value is, again you have to multiply with 800. 800 into 31 by 32, you will get the totally 775 families. So this is about the families. The first 4 problems means first 3 problems are about the die or about the coin. Now it is a family. In the family also we have the P comma Q values are equal because there is a boy or girl only in the family. So means the meaning is very clear. It is a male or female. Now going for a fifth problem. The fifth problem is it is a fit a binomial distribution for the following distribution. So if sometimes it means fit a binomial distribution means you have to find the binomial values of for the x values and you have to fit it. Suppose they given x is equal to 0, comma 1, comma 2, comma 3, comma 4, comma 5. So I have to take n is equal to 5. And f values they given, that one is 2, comma 14, comma 20, comma 34, 22, comma 8. So summation of f you have to find it 2 plus 14 plus 20 plus 34 plus 22 plus 80, and these are is equal to 100. Now we have to find the mean. For the mean distribution, that is nothing but summation of fi xi by summation of fi. So we will get 2.84. And after that, finding the mean. So the mean of the distribution and mean of the binomial distribution is nothing but NP is equal to 2.84. Then from, you know the n value, but we don't know the p value. From this one, we can find the p value. So here using this NP is equal to 2.84. So from that one, P is equal to 2.84 by 5. So we'll get 0.568. Then Q value is 1 minus P, that is nothing but 0.432. And after that one, you have to take the each and every value. So x is equal to 0 and x is equal to 1, x is equal to the values, you have to take it and you have to fit it. So here is here how to do this one. So first x is equal to 0, phi is 0, p power 0, q power n minus 0, that is nothing but 0.02. So n into that one is, n is nothing but 100, totally 100 is there. They given means you got it totally p summation of f is equal to 100, 100 into 2, that is 2 value. And if x is, r is equal to, if r is equal to 1, then again you will get 0.09 into 100, again you will get the 9. If you take x, r is equal to 5c2, these are the same thing, 0.26. The final answer is 26. In the similar way, if x is equal to 3, the answer is 34. If x is equal to 4, the answer is 22. If x is equal to 5, the answer is 5.9. So this is about the binomial fit a binomial distribution. So this is nothing but about how to fit the binomial distribution and how to check it whether the values will be equal or different. It is approximately same. If x is equal to 0, the value will be 2. Here also x is equal to 0, the value will be 2. And 1 is equal to, that is nothing but 14. So it is somewhat it is equivalent. So 2 is equal to 20, here also 2 is equal to 26, and 3 is equal to 34, here also you are getting 3 is equal to 34, and 4 is equal to 22, you will get the 4 is equal to 22. And last one is 5 is equal to 8, and here you got it, 5 is equal to almost 6. So like this, you have to check it. Means almost the values all are same, repeated only, means it is equal only. So after this one, these are the basic and basic problems of your binomial distribution. And after that, we have one more recurrence relation is there in a binomial distribution. So that is nothing but P of r plus 1 is equal to NCR plus 1, P r of r plus 1, and P power q power n minus r minus 1. So from this recurrence relation, we have to notice that one. So this is the property, that is P of r plus 1 is equal to NCR plus 1 by NCR, that is NCR into P power r. So this is a recurrence relation of binomial distribution. So this is about the binomial distribution today topic. So there are some examples. I explained that one, and after that fit a binomial distribution also. So I hope everyone should be understood. Uh, thank you, thank you very much.